Hello and welcome to yet another video of Cornerstones of Math. As for today's problem, the problem itself is pretty simple. We have to solve the equation 2 to the power of x squared times 3 to the power of x equals 144. And I will present you two methods. These two methods are actually quite powerful and thereby widely used when solving various types of exponential equations. So let's get right on to them. The first method is converting the given equation into the form of fx to the power of gx equals 1. Now instead of just memorizing this, let us understand why we are trying this method. What good does this equation fx to the power of gx equals 1 do? Well, the benefit of this equation is, when the right-hand side is 1, there are only a handful of cases where the equality holds. Only 3 cases to be exact. The first case is when fx is positive and the exponent gx equals 0. The second case is when the base fx is equal to 1. And the third case is when fx equals minus 1 and gx is a positive even number. Alright, so let's convert the given equation into this form. We can easily find the prime factorization of 144, which is 2 to the power of 4 times 3 squared. Now, in order to make the right-hand side 1, we divide both sides with 2 to the power of 4 times 3 squared, which gives this, which can be written as 2 to the power of x squared minus 4 times 3 to the power of x minus 2 equals 1. Here we can factor this x squared minus 4 and write 2 to the power of x minus 2 x plus 2 times 3 to the power of x minus 2 equals 1. Notice that now we have a common exponent x minus 2. Therefore, we can write 2 to the power of x plus 2 times 3 to the power of x minus 2 equals 1, which is this form. Now, this base part is always positive, so it cannot be minus 1. Therefore, there are only 2 cases left for us to investigate, which are either the exponent x minus 2 equals 0 or the base 2 to the power of x plus 2 times 3 equals 1. So for the first case, when x minus 2 equals 0, we have x equals 2, which is a positive root. And now for the second case. This is a simple exponential equation where all we have to do is to write 2 to the power of x plus 2 equals 1/3. So x plus 2 equals log base 2 of 1/3, and since log base 2 of 1/3 is minus log base 2 of 3, we have x equals minus 2 minus log base 2 of 3, which is a negative root. Therefore, from cases 1 and 2, we have roots x equals 2 and minus 2 minus log base 2 of 3. So that was the first method. The second method is using good old logarithms. Taking logarithms on the given equation is a well-known method to solve exponential equations, especially when the given equation contains different bases, such as this one. But why do we take logarithms? In order to understand that, let us actually take logarithms to see what happens. First, let us write the right-hand side as 2 to the power of 4 times 3 squared. Now we take logarithms on both sides. We can take log of any base, but since 2 is one of the bases in the given equation, let us take the log with base 2. Now logarithm has these famous properties of splitting a product into a sum and extracting powers. So using these properties, we have this part becomes x squared, and this part becomes plus x log base 2 of 3 equals, this part gives 4, and this part gives plus 2 log base 2 of 3. And this is basically the reason why we use logarithms. Since logarithms extract powers and bring them down to the base, we can convert the exponential equation into a polynomial equation. In this case, we have a quadratic equation. Here we can write the equation as x squared plus log base 2 of 3x minus 2 times 2 plus log base 2 of 3 equals 0. Here, the left-hand side is actually factorable using this formula. Here we have this product, and the coefficient of x is actually a sum of minus 2 and 2 plus log base 2 of 3. So we have x minus 2 x plus 2 plus log base 2 of 3 equals 0, which gives x equals 2 and minus 2 minus log base 2 of 3. And that was the logarithm method. Thank you all for watching. If you enjoyed this video, please give it a like and also subscribe to my channel. And as always, I will see you in another video.